1.5. We are picking up where we left off yesterday. If you recall, we had talked about functions defined implicitly where they're not solved for x or y. We had talked about parametric equations, and I showed you the parametric mode on the calculator. And we were starting to talk about inverses. And so here we use the vertical line test for is it a function, the horizontal line test for does it have an inverse. And now, in example 4, we're going to talk about finding the inverse function for each of the following if one exists. Okay? So, technically something we did back in Algebra 1. Okay? First of all, what do you know f of x to be? F of x is a fancy way to say y, right? So this equation is the same as saying y equals x over x plus 1. True? Okay. To find an inverse, I mentioned it yesterday. And it mentions it on the bottom of the front side of the notes. But to find an inverse, what has to happen with x and y?
Switch them.
You switch them, right? To find an inverse function, switch x and y, and then we will solve for y. So when we say switch x and y, that means every place I see a y, I write x. Every place I see an x, I write y. So instead of y equals, I'm going to say x equals. Instead of x over x plus 1, I'm going to say y over y plus 1. Okay, so if you want a little side note here, what did we do? We switch x and y. That is our step 1, so to speak. After you switch x and y, the next job is to solve for y. So, I'm going to need room to write a step there, aren't I? Okay, solve for y. Okay. This is not the easiest one to solve for y. We'll have some easier ones for sure. But our job is to get y by itself. First of all, there's a fraction. How do you deal with a fraction? Okay. If you're trying to get it so it's not in fraction form, like right now it's y divided by y plus 1. The opposite, dividing by y plus 1, is to multiply by y plus 1. So I'm going to multiply both sides of my equation by y plus 1. Okay. Are you talking about on the right? Yeah. On the right, because I'm multiplying the y plus 1 times a fraction, you can think of it as y plus 1 over 1. With that in mind, the y plus 1s will cancel, right? On the left, notice I have it as y plus 1, and I put it in parentheses because it's a quantity, times x. How can I multiply those? Okay. This x can distribute to the y, and the plus 1 is just written out back instead. So when I distribute that, x times y is xy, plus x times 1 is 1x, equals, on the other side, y plus 1's canceled, so it's just equal to y. Are you with me?
And that's your answer?
No. My job is to solve for y, but why is that not my answer? There's also a y over here. And if it's solved for y, that means it's y equals, and the only y is that y that is y equals. So, in order to make this happen, we need to get our y terms on the same side. Okay. I know we generally say left side. However, I already have a y on the right. Could I move this other y to the right to join it? How do I move the xy term?
You're subtracted.
Which is it?
Subtracted. I thought you were just going to say a y.
Okay, no. We're going to move the whole term I don't want to just divide y. It wouldn't work out very pretty. Okay, so we're going to subtract this term. So I'm going to subtract xy over to the other side. Now, as I write it in the next step, can you guys handle it if I flip-flop my sides? You guys okay with that? So, in other words, I'm going to put my y minus xy on the left equals, then what's going to be on the right? Xy's cancel, and so we're just left with x. And as I said, this is a more difficult problem. Okay? Didn't really start with the easiest problem. I think you'll like the others better. Both terms have a y, yes? My job is to solve for y. So, let's factor out a y on the left. In other words, GCF. If we factor out a y, that means the y is going to go out front. What remains in the parentheses when you factor out a y?
1 minus x.
Okay. Y divided by y is 1 minus xy divided by y is x. And of course, this equation still equals x. Okay. On that left side, I have y times 1 minus x. How do I solve for y if it's y times something?
Y.
Yeah, if it's y times something, we're trying to solve for y, we're going to divide by something. So I'm dividing by, what is it I'm trying to get away from y? 1 minus x. What I do on the left, I do on the right. Okay. So then I end up with the equation y equals, because my 1 minus x is canceled, and y equals x over x minus 1. And that's your inverse function, because we got it to be y equals. If you leave it as y equals x over x minus 1, I can live with that. The other option, remember that inverse function notation is to say f inverse of x is equal to x over x minus 1. Okay? So just don't forget that inverse notation exists. I'm not usually too big of a stickler about it, but you need to know that that is the appropriate way to handle it. Okay. I would say, in my opinion, we probably got the toughest one out of the way to begin with. Okay. So if you're feeling like, ooh, that was tough, it was. I think the others will go a little smoother. Questions I should answer before I move on to B. Okay. So, first of all, f of x is another name for what?
What?
Y. So I just crossed my f of x out this time and wrote y above it. So this equation is really y equals square root of 4x minus 3. Trying to find the inverse. What's my job to find the inverse?
Switch x and y.
Okay. Take x and y and switch them. So y equals becomes x equals. Square root of 4x minus 3 becomes square root of 4y minus 3. Okay. My job is to solve for y now. So, thoughts on what I need to do to solve for y? Karina? Yeah, square it. That y is under a square root. How do I get rid of the square root? We're going to square it. If you square the left, or excuse me, I guess that's if you square the right, you square the left. When you square the x, it just becomes x squared. I think you guys all know when you square a square root, you just get whatever's under it. So 4y minus 3. Are you seeing this one? Is this one more doable? I like this one better. It's easier to teach because you guys know what you're doing. It's 4y minus 3. How do I get y by itself? Since it's 4y minus 3, I'm going to add 3. I'm going to flip my sides if you guys can be okay with that. So minus 3 plus 3 cancels. 4y equals, and I have x squared and plus 3. What do I do to finish this off? Divide everybody by 4. Now, we can do this 2 different ways. Trying to decide how I want to write it.
Just like the whole thing.
Yeah, I debated. We can divide both pieces by 4 like I just wrote. Or could you just divide the whole thing by 4 and make it one big fraction?
Yes.
You can. And honestly, I would take either or. It really just kind of depends where we're going with it. Like right now, we're not going anywhere with it. It depends, you know, do we have to graph it? Do we have to plug numbers into it? If I have to graph it, I'm going to make it 2 forms, 2 pieces, because I want mx plus b. If I have to plug numbers into it, this isn't mx plus b, but x squared plus a number. If I have to graph it, or if I have to plug it in, I just want one big fraction. So, either way, you can either write this, like I could write this as y equals x squared over 4 plus 3 over 4. Or you could write it as x squared plus 3 all over 4. Okay? Officially, the y equals is the same as saying f inverse equals. So I can either put x squared over 4 plus 3 over 4. Or, if you want to see the other one, f inverse of x equals x squared plus 3 over 4. To me, what's important is that you understand those are equivalent. Okay, that's what I would say is important there. Okay, see? Okay. Are you guys ahead of me already? F of x is the same as y. To find the inverse, what's step 1? Take your x and y and switch. So instead of y equals, x equals. Instead of 4x squared minus 7, 4y squared minus 7. Okay. How would you like to solve for y? Okay. If it's 4 times y squared minus 7, I would agree and add that 7 over. So then I have x plus 7 equals 4y squared. Okay. To get y squared by itself, divide by 4. Now, this one, I'm going to do it the other way. I'm going to leave it as one big fraction. At that point, I'm going to flip my sides. I have y squared equals x plus 7 over 4. Okay. If it's y squared equals, we're going to square root. Now, a couple of things here. You guys know if we square root the left, we square root the right. Square root of y squared becomes y. When you take a square root in an equation setting, we have to put out front a plus or minus. Now, okay, we could say the square root of x plus 7 over 4. However, 2 things. 1, it's not usually considered proper form to leave a fraction under a radical. But 2, what do you notice about that denominator? The square root of 4 is 2. So another way to write this,
Square root of x plus 7 over 2.
okay, plus or minus the square root of x plus 7. So the fraction bar is just on top. And then the square root of 4 is a 2. So it's just a plain old 2 on bottom, and it's not under the radical. So f inverse of x is plus or minus the square root of x plus 7 all over 2. Okay, that is common to see a problem where you can take the square root of the denominator. But technically, square roots, you can't have fractions under square roots, and you can't leave square roots in your denominator. Okay, so this is definitely an Algebra 2 skill we did. B and C weren't bad, right? It was a tricky one to solve. I get it. I started you in on the difficult one, but hopefully B and C look attainable. Okay, so inverses. X and Y switch. Now, that leads us into this next piece. We're going to talk more about inverses. First of all, the inverse reflection principle. A function and its inverse are symmetric across the line y equals x. So a function and its inverse are symmetric across the line y equals x. What is the line y equals x? Line y equals x? What is it? That's the line that has a slope of 1 and a y-intercept of 0, right? I'm just trying to get you guys to think mx plus b. So it'd be 1x plus 0. Are you with me? Okay, so when we talk about the line y equals x, we're talking about what you'll sometimes hear referred to as the perfect diagonal line. It's a line that goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, and all of those. Okay, so that's if two things are inverses that reflects across that line. And the reason is because your x and your y values switch. So it reflects across that line. Okay. We're also going to talk about the inverse composition rule. And that is the idea that a function is one-to-one with an inverse function, g, if and only if f composed with g of x equals x and g composed with f of x equals x. Okay, so basically you can figure out if a function is one-to-one or if they're inverses by figuring out does fog equal x and does goth equal x. Okay, so the two pieces we're going to talk about here. Okay, let's look at example 5. Sketch the graph of the inverse function for the function drawn on the grid provided. So you see this function, yes?
Mm-hmm.
Okay. Our job is going to be to reflect it, okay? We want the inverse. And there's a couple of different ways to think about this. Inverse. Remember, any point that is xy now becomes yx. So one option to do this, can we pick some points on our current graph? Okay, for instance, let's see what we have here. Could we agree it looks like the graph goes through negative 1, 0? Yes?
Yeah.
I'm just picking a point here. So if my graph goes through negative 1, 0, what is that going to be on the inverse? Take your x and y and switch them. So it's going to be 0, negative 1, which is left or right, 0, and down, -1. I'm going to make my inverse points red, I think. Okay. What else do we have here? Does it look like the graph goes through 0, 1?
Yeah.
Can you guys see my points okay? They're not huge, I know, but goes through 0, 1 here. So what does 0, 1 become on the inverse? 0, 1 becomes 1, 0. So now I'm going to have a point that is 1, 0. I'm making the red points my inverse. Okay, you want to pick another point?
Maybe 1, 2.
I could go with that. Does it kind of look like this graph goes through 1, 2, or about that area? This isn't going to be exact, okay? I'm just trying to get you guys. So if it goes through 1, 2, what do we know? 1, 2 in the original graph becomes what? 2, 1 in the inverse. So now right 2, up 1. Okay. Kind of looks like a straight line, doesn't it? It's not. Okay. Let's see. One thing I can do is I'm going to kind of put in here the line y equals x. The line y equals x is that perfect diagonal line that goes through points like 1, 1, 2, 2, 3, 3, 4, 4. Okay, so for reference, that's the line I'm reflecting across. One other thing I can think about here before we try and draw this. And this is a tough one to draw, okay? Do you see my current graph? Does my current graph touch the line y equals x? It looks like it crosses the line y equals x. I don't have a point for that, but about right there, yes?
Yeah.
If my graph crosses the line y equals x and say that's, it's not exactly, but say it's -1, -1. Well, -1, -1 on the original graph is going to be what on the inverse? -1, -1. So it's going to cross that graph at the same point. Now, okay, the other thing is, as we draw this, think about it. This line is going down right here, yes? If you take this line that's going down right here and you reflect it over here, we're reflecting across this line. And it's hard for me to do this on the bin Q, but I'm going to reflect across this diagonal line, yes? So fold your graph at the diagonal line. This line over here is now going to be going over this way. Okay? So I can think of it that that line here is going to be over in this area. Notice we're going to connect through this dot. What's your graph doing between these two dots? It's curving away from that diagonal line. So I'm connecting those in a curve and it's away from it. What's my graph doing between the next two dots? It's going towards that diagonal line. So now I'm going to curve towards that diagonal line. Now, this graph goes up. My graph, because I'm reflecting across this diagonal line, visualize it. If you fold your paper at diagonal, it's going to go out that way. Okay, that's an attempt at our graph. Okay. Questions I can answer on that? I tried to explain as I went. Or do we just not even know what questions to ask on that one?
I mean,
It just comes down to when you do it on your own, you know.
You're going to have to sketch a graph and run it.
Trying to remember what all's in homework. Maybe? I don't remember what all's in homework. I'll check that here in a moment. The key is, notice I'm switching points. I'm using that line as a visual, okay? Okay, one more then. Example 6. Ask me to show algebraically that f equals x cubed plus 1 and g equals the cube root of x minus 1 are inverse functions. How do I show algebraically that they are inverse functions? Fog has to work out to be x, and Goff has to work out to be x. So, some of you guys were good with Fog and Goff. Some of you guys struggled a little bit. Let's practice. So if I start with Fog, f composed with g of x. F composed with g of x is also written as f of g of x, correct? I'm going to take g and I'm going to put it into f. So if you will, this is f of, what is g? Cube root of x minus 1. So I'm going to take cube root of x minus 1, and I'm going to put it into f. What is f? F is, can we agree it's something cubed plus 1? What am I putting in for the something? The cube root of x minus 1. I don't know if that helps or not, the way I did that.
Really? It all equals.
Yeah. What happens when you cube a cube root? The cube root and the cube will cancel. I then have x minus 1, and then we have this plus 1 over here. What is x minus 1 plus 1? It is x. And is that what we needed to happen? Yes. Okay, we got Fog to equal x. I'm not done though, because what else has to happen?
Goff has to also equal x.
Goff. G composed with f of x. So g of f of x. I'm going to take f and put it into g. So f was x cubed plus 1. I'm going to take x cubed plus 1 and put it into g. Well, g says to do what? G says to do the cube root of something, right? Minus 1. What am I putting in place of x there? The x cubed plus 1. Okay, clean up. What is x cubed plus 1 minus 1? The ones cancel. So I have just x cubed. What's the cube root of x cubed?
X.
X. Hey, guess what? Is that what was supposed to happen? It is. Okay. So there's not an answer there, so to speak, because it just said show. We showed. The work matters here. Okay. I just realized, so on the homework, is it 112 or 122? It's got to be 122. 112 was 144. Was lesson 140. Okay. Sorry. So page 122, 1 through 6, 9 through 12, 14 through 22 evens, and 23 through 29. I just caught in my notes that on 14 through 22 evens, it must say something about domain. And I'm saying no domains. Okay? And I'll double check that in the book, but that must be what I was thinking at the time. Okay? You have a little bit of work time. You got about 10 minutes.